most critical time after an accident for an investigator is shortly after to get scene evidence, because it's going to go away. There'll be paint marks on the road. People have probably seen those driving around that show the final positions of the vehicle.
So what can drone footage capture that ground-based investigation misses?
And getting a good aerial view right over is a really good way. Then you can input it into software and be able to have your scale model.
Hello and welcome to a brand new episode of On the Stand with Ashish Arun, where we explore the law, practice and business of expert witness testimony. Today, we are joined by John D. Zeirke, a mechanical engineer who has made the transition from designing some of the world's largest vehicles to investigating why vehicles fail. John is a licensed professional engineer in 6 states: Minnesota, Wisconsin, Illinois, Iowa, North Dakota, and South Dakota. He holds ACTAR certification as an accident reconstructionist, NAFI certifications as both a fire and vehicle fire investigator, and is an FAA certified commercial drone pilot. His industry background is remarkable. John spent nearly a decade at Caterpillar, where he designed planetary final drives for the 797 Ultra class mining trucks. These are 400-ton payload machines with wheels taller than 2 people stacked on top of each other. His major project there was developing the first electric drive mining truck Caterpillar had ever produced. From there, John joined Polaris Industries, where he worked on the Slingshot, that distinctive 3-wheeled roadster you've probably seen on the highway. At Polaris, John wore 2 hats. He was the system owner for the driveline, and critically, he led product safety and quality investigations. This role had him evaluating potential recalls, investigating field failures, and presenting findings all the way up to the boardroom. In 2018, he transitioned to forensic consulting at Rimkus, one of the largest consulting firms in the country. Earlier this year, he launched his own firm, JZ Engineering, based in the Minnesota Twin Cities. He has testified in federal court and state courts across multiple jurisdictions on matters involving mechanical failures, vehicle fires, and accident reconstruction. What makes John's perspective particularly valuable is that he has been on the other side. He knows how the sausage is made inside major manufacturers. He's sat in those recall meetings. He understands what documentation exists, what testing gets done, and how companies investigate their own products. So on that note, let's welcome John to the stand. John, welcome to the show.
Yes, thanks for having me.
Yeah, it's a pleasure to have you here. So you've said that expert witness work isn't exactly something kids dream about growing up. And probably because I don't really think most kids have heard of expert witness work. So how did you first become aware this career path existed?
Yeah, I would say I first became aware of engineers doing expert witness work from a professor I had in college for machine design. I had him in a couple things, senior design. And he would bring in those anecdotes into lectures and stuff like that. But at that age, you know that, okay, I'm not going to just be doing this right out of college. You need experience to do it. But that was just like one little note. But I would say forensic engineering in general does not get a lot of push or really any knowledge. And it's something that you can get into. There are people I've talked to who have gotten into it just by getting with the right company out of school, and then they could start along that forensic path. But I think in general, and like, for example, when I got my PE first, I was still at Caterpillar. I just kind of did it. I think I had some notion that there might be a potential for people, if you get your PE and progress, that it would be helpful in doing something different. But when I left Polaris to go to Rimkus, that was like the biggest career change. And I just remember at that time, colleagues of mine not even really understanding that this was something. You're like, oh, that sounds actually pretty cool, but like it's not on everyone's radar. You kind of think about the design side, and that's obviously where I went right out of school. It's kind of the more standard path, and it's great. I think for me it was the best thing to do to get that baseline of experience, and then you have a lot more to lean off of when you start going into the forensic side.
Yeah. So let's talk about your time at Caterpillar. Like, you were designing components for 400-ton mining trucks, and the kind that most people never even see in their lifetime. So what was that work like?
Well, yeah, I mean, we didn't see them at the plant. You had to go to the mine site to actually see them fully built because they build them at the mine site. So yeah, I mean, Caterpillar is obviously a huge company, Dow Jones established company. And there's a lot of people and we got I got hired into the lower powertrain group, which did essentially rear axles and driveline for all the different Caterpillar products. And then within that, you had sub teams where we focused on specific vehicles. So I worked on the ultra class, what they consider ultra class, from 180 ton to 400. Model number was like 785 to 797. And I started in 2005 out of college. And that was at a point, the entire ultra class size truck thing started probably in the late 90s. And so it's still relatively new. And there was a bigger push to make them bigger and, and better and everything. But competitors to Caterpillar had kind of gone with a diesel electric, essentially hybrid type of a driveline. Caterpillar always had mechanical drive components. So all the trucks that had been there before I started were engine, transmission, differential, and of course, planetary final drives you need on there to even multiply the torque to carry that much payload up a 8 to 10% grade. And so the speeds are low, but they need the torque. So they always had these planetary. When I came in and I had design ownership for those mechanical trucks kind of throughout, there's maintenance and different projects you're doing on that. But I think the big project in the time I was there was those first couple electric mining trucks. And the challenges with those were, as you can imagine, the input speeds to those final drives goes up significantly when they're coming from an electric motor. So torque down, speed up. We needed a bigger ratio combined, and they were 2-stage planetaries, and so now we're going to a much bigger ratio. We had to go to a different configuration. I don't know how much you want me to bore you with all that, but it was interesting because it was a clean sheet design, something I had control for. I was doing the CAD, I was doing the planning. There was a lot of very experienced people at Caterpillar. That's a great part of that company. So a lot of help with design reviews and everything. But even for the people who are really experienced with it, we found issues that we maybe didn't anticipate or didn't anticipate it would be as critical. And mining's crazy because every mine is kind of different. You have like deep pit hauling uphill mines. You have in Chile, they're mining the top of the mountain and driving down, and you're kind of in a reverse torque situation. And then sometimes they're driving, it's, fairly surface mine, and they're driving long distances in a flat environment. And so speed is more of a concern than torque even. So I think that was a key part of my development was the opportunity. And it just was good fortune, I guess, that I was able to come in. And it was kind of like drinking from a fire hose a little bit because I was getting my head around everything and just the processes of working as an actual engineer versus school or versus even being an intern or co-op. I co-opted a company throughout college. But yeah, once you are like a full-time employee and you have the design control and they're your prints, you're trying to get as much help from people as you can. But that's kind of when you level up, is when it's on you and you have to see it through the whole design and development process. It's a grind, but it's rewarding when you see the final result.
Today's episode of On the Stand is brought to you by Xlightum, the AI-powered platform where attorneys find expert witnesses and experts grow their practice. Every week, hundreds of new experts join Xlightum, giving attorneys instant access to qualified witnesses without any finder's fee or markups. Need someone else to handle the vetting? Our concierge service does it all. You only pay when you retain an expert we present. So whether you are searching yourself or letting us do the heavy lifting, Xlightum makes expert discovery fast and smarter. Visit Xlightum, that's exlitem.com, to find your next expert witness today. Yeah, and you also got 3 patents from that time while you were at Caterpillar. So were they related to the same electric drive mining truck?
Yeah.
Or
So yeah, and certainly, they look to patent whatever they can on it. When a new design happens, that's going to be part of the general procedure. So one of them was really kind of focused, and I shared it with a few other people, and it was focused on the packaging and the configuration of the entire rear axle and driveline. So that was a part. My components, I guess, played into that. And then the other one is actually the other two that are very similar, related to essentially an issue we had with windage in the planetary carrier rotating through the fluid, and the amount of heat that generated just from the speed, not so much the torque interaction. And so we fought some issues early on about oil temperature management. And as part of concepting, ideating, and doing some stuff in the lab, we had some different ideas that worked, and not necessarily going to production in that exact form, but yeah, that's generally what that was about, was tailoring a design for the purposes of helping the windage, even if it wasn't required from a torque standpoint. And so that's probably one of the main learning points for us, Caterpillar, is you went from being so torque focused on you're trying to carry the huge loads uphill, or at the tar sands, you got really soft conditions sometimes. So it's torque that's going to get you. And that's what gear design, bearing design, you're looking at stiffnesses of different components and assemblies, and you're in that torque mindset. And then the electric drive all of a sudden opened up a whole bunch of low torque, high speed failure modes that we had to consider, critical speeds of shafts that were now spinning way faster. And even bearing interactions within the rolling elements and the cages, they react differently under low load, high speed, and then oil management and flow and everything. So yeah, a lot of learning experience in that.
Mm-hmm. And then you eventually made a shift to a three-wheel roadster. So can you tell us about that? Like, what drew you to Polaris and the Slingshot project?
So I had some talks with Polaris over the years. First of all, the area. My wife and I had friends. I'm from Wisconsin, but we had friends up here in Minnesota and had spent a little time up here, and it seemed like a state that we would enjoy living in, or be open to moving to. But in the process of talking with Polaris on and off, I became aware of this development center they have north of the Twin Cities, kind of off in the woods. And they built it, I don't know, 15, 20 years ago, maybe. And it's just this awesome thing for engineers. They got the offices you're designing, but then like right over the wall, there's all these bays where you build stuff, they test stuff on site. It's a very much of a hands-on environment. And because the parts are a lot smaller, you can actually move stuff around. Everything I designed at Caterpillar required kind of like a crane to lift it. I couldn't, most everything you couldn't touch, and it took a long time to build and different things like that. And I certainly was never driving those large mining trucks. I was riding along in them sometimes. So at a point, you're kind of looking for maybe a change. And then there was different products and different opportunities, but nothing ever seemed like mutually were like not a great fit. But I was on their radar, and then all of a sudden they had this thing called the Slingshot they were working on in the background, a very small group of people that were kind of working on it, making the product, testing it, and getting people excited about it. And before they hired me, they had made that decision of, okay, we're doing this. We're going to production. They had some concerns about regulatory and whatever. But at some point, they made the decision, we're going, so we need to staff up a team, and we need to take what's a cool product and what we've built and tested that we love to something that we can go to production and make at volume.
Mm-hmm.
So that's where I came in. I came in before they publicly launched it and before we went to production. So I got to see some of the development, but I was not from the clean sheet design of that vehicle. But in terms of getting back to what you're talking about what attracted me, that is the exact type of vehicle that I'm into. Like
Mm-hmm.
there's a lot of maybe confusion because they had to like call it a motorcycle. It's not a motorcycle to me. It's a small little roadster that is rear wheel drive and manual transmission, and you can drift it around. And so I just thought that would be a cool thing to work on, and it was. And And then just the nature of how things go at Polaris, it's very hands-on for engineers. Go out to the shop, you have a new part, and I was doing driveline. You have a new gearbox or something, or a belt drive or something. Go out there, install it, and then take the thing home for the night, drive it around, do that type of stuff. So it was really cool. It was
Yeah.
a big difference from Caterpillar, not only on the stuff I worked on, but it's like really big company to smaller company. It's still a large company, but it really acted like a small company. And we were a really small team. And the very beginning, it was like all hands on deck. So I was working on any different type of part of the vehicle. It was like a list of things we need to get done for production, including on the manufacturer side, but also supplier quality. And it could be a paint issue or something, trim piece or something. And so we kind of worked together. That first year was pretty intense and cool. And then we got to production. And then what happened there was pretty much after that first year of production, going back a little bit, that original Slingshot has a GM engine. They sourced the engine from General Motors. It was in the Pontiac Solstice and stuff like that, and then built the vehicle around it. And there was a fairly short time into it, they decided to sunset that engine. So we were going to need a new engine. And the demand for the vehicle was very quick off the gate. And we're like, oh my God, we're going to run out of engines. And we went through all sorts of different options, but they decided to build their own engine because Polaris builds engines for everything. But they designed a 4-cylinder inline engine capable of revving over 8,000 RPM and designed in potential for power increases. But that is such a huge scope program, and that ended up opening up an opportunity to have a program large enough to make major changes. Otherwise, you're kind of like locked into certain designs and you're kind of trying to improve them as best you can, but it's really that opportunity to kind of do a major change. So it's really kind of like the second generation. And it was challenging because you're doing the powertrain guys were working on the engine. We're working on the chassis and all those systems. And you keep going back and forth, but you're building prototypes, testing them, making design changes, putting new stuff in, revalidating, and everyone's doing it all together. And that probably started shortly after I began there, maybe a year or two. And when I left for Rimkiss, the design was pretty much baked. At least my driveline was baked, and we had sorted through some of the issues. But it was still a couple of years. I think it was the 2020 model year that it was released. And now they've done a lot more improvements since then. But yeah, they really beefed up the steering, brakes, like every system got touched in that large program. And it was obviously fast paced, and a lot of attention on it. So again, great experience. And then at the same time, you get enough of these vehicles out on the road. And that's kind of where the other role was added for me, for having somebody who was embedded in the Slingshot team that could keep tabs on all the different inputs coming in from warranty or customer complaints or even social media, like keeping on top of, we're hearing about this issue or somebody's complained about this or that. And of course, with power sports in general, a lot of things, but power sports specifically, you get people driving things pretty hard, having accidents, and then a certain percent will always blame the vehicle, right? So you need to understand that. But at the same time, too, it's a new vehicle, a lot of new content, and there were issues as well. So what things are real, what things are maybe more warranty, reliability, what things are safety critical and need to be escalated. And so I was kind of at the top, and we're working that funnel, well, either down or up, whatever you want to describe. But along the way, did a lot of testing to try to replicate failures that happen, which was cool. And I guess where that's kind of what really started attracting me to the forensic side is you're basically doing forensic engineering when you're a design engineer doing product development, because you need to get to that point of understanding why something broke and what you can do to solve that issue. You need to do that loop as soon as possible, as intense as possible, because once you know your parts that you're going to, know what the fix is going to be, the new parts. There's tons of details and blocking and tackling that have to happen to implement it. Even when you recall something,
Mm-hmm.
there's a race to actually, I mean, if you get it for like a recall for your car, sometimes they're like, yeah, we're recalling this, but we don't have a fix yet. And so it's because they're validating, and then you actually have to manufacture all the part, whatever part you're going to be using to fix it or process or whatever. That all has to get implemented, but you can get a lot of support in that direction from manufacturing and supply chain, but they look to the engineer to get to that answer as quick as possible. They don't want you to be, dilly-dallying around or spinning your wheels, so to speak, on, we can't figure out the problem, or, we don't know which direction to go. And one of the things I learned from the design side is sometimes you recognize pretty early that, okay, you know what broke and why it did. And then you look at what are your options. And sometimes you're like, man, what we really need to do is this kind of bigger design change. And this is going to take a lot of money and time, most importantly. And then the slingshot was very weight sensitive, or like critical. You could not add weight because of we were up against some regulatory stuff on that. And just generally, it's a performance vehicle. You don't want to add weight. There's sometimes those solutions that you identify based on what you come to realize about an issue. You're like, I really want to do this, but this is going to take forever, or it's going to be a big scope. And maybe they'll approve it, but it's still going to take time. But we know we have some issue that's going to have a certain failure rate that we want to address. Then you identify maybe there's an interim fix that we think will be 90% of the way there, but we can implement it really quickly. And I'm a believer of doing parallel paths of those two. Like, let's not wait until we can get something perfect. And I'll be honest, I've had some things in the past I thought were 90% solution, but once we implemented them for a while, we realized it was actually like 99%. Nothing's 100, but in the real world, things that you test that you're like, this is an improvement, but maybe not everything. But then it turns out in the real world, it's pretty good. So that's a reason to not just completely wait till you have what you think is the perfect solution. That's kind of where I'm at, is to let's try to, especially in terms of a recall, okay, let's address what we need to address and plan for the next big change, big program, and just button it up, or just be more efficient about the fix. Like sometimes, especially a Caterpillar, these gigantic parts take forever to make, and you want to work within the design because it just takes so long to make, a major change to a ring gear that's like 1 meter in diameter. So, but yeah, that's all the experience that kind of comes into play. But I found too, though, that it's very intimidating when you come out of college and you have some sort of issue. You're always everyone's going to have their turn at having some issue that's hot. And then if it's holding up production or it's holding up the development for everyone else, like, you're going to get all this attention. And it's really intimidating when you're right out of school. But I actually found at some point, you don't want issues, you still try to avoid them. But I was like noticing that, like, when things elevate, it's like a lot of red tape goes away. I remember there was a time earlier in my career at CAT where we had some prototypes in the field, and it always happens on a Friday afternoon. Something happened, and I needed to build. You don't just build replacement parts immediately. And so I had the plant manager's phone number for the week, and I was there, and I had some, assembly people with me. We were all focused, and we were there like all weekend doing this. And that was a stressful, but it was also kind of like exciting in a way, I guess, but rewarding as well. And you got to kind of earn some respect with the older people for coming through. That's what you have a lot of times, is like you have to recognize in your career in general, like when this is like a key time and I got to step up. And there's those times along the way, but in some ways when it's like, okay, all your maybe extraneous meetings or whatever responsibilities, they let you like put all that aside because you're focused on this one thing for a very short amount of time. And that's kind of forensic engineering. A lot of that, you're getting to the bottom of something and you're focused really on the core technical side. Whether I was working at a company like Rimkus or on my own, it's very like my workload is extremely focused on what is important and core to what I provide. So
Yeah, that's what I was wondering while you were explaining the recall investigations and that aspect of the work that you were doing at Polaris. Like, would you say that it laid down the foundation for you to eventually make the transition into forensic investigations? Because as I can see, you were investigating complaints, and then after that, you like a big part of your job was also to escalate it to the boardroom, which would be then, I mean, they would obviously know more than a jury would about the parts, but still, I mean, the executive, assuming that they were not all engineers, was explaining the investigation outcomes and explaining the technical into a more business friendly way, a part of your job description or task at that
no,
point.
that was a big development area for me. And I think it is natural for engineers. Like somebody, it was a manager who was a couple levels above me. He's like, I asked you what time it was, and you told me how to make a watch. We're so into the detail. We have so much floating around in our head, and you just want to like show that you know what you're talking about, but also you just want to inform them, but you're like overloading them. And this really does come into play with being an expert witness. We're reporting to an attorney, and a lot of attorneys are actually pretty technically smart especially if they've been doing this type of work for a while. But still, um, they're like, what is important, especially like an assurance adjuster specifically. You're like, they just want to know like what's the bottom line of something. And then also in our report writing and the way we present in testimony, if you're talking to a jury or just in terms of even writing a report, and I think it was key to work at a company like Rimkus where we worked with a lot of people who were really experienced about that, and just the way you word things and the way you organize your report to explain your methodology, just even that process gets you thinking. But yeah, it was like every step along the way, and it was a team decision to escalate always. There was regular teams that reviewed issues every week or whatever at this level, and then something you'd either you'd either work it in the quality path or it would go up. By the time you got to the big boardroom, like you
Mhm.
knew you were recalling it, like, and they all had been kind of prepped a little bit too, and you're kind of more talking about what's the timeline and the plan and all that. But certainly too, yeah, it's always been a challenge. I continue to try to like focus on that area. Okay, how can I really get to the bottom of something and really, in my own mind, consider all the really small details and everything, but how do I go to actually explaining that? And in terms of expert witness work, it's key because a jury, if they're just like, if their eyes glaze over, you're not really being an effective witness, really. Like, they need to feel like, yes, you're competent and you know what you're talking about, but they need to even like grasp what you're talking
Yeah.
about. And, and yeah, I mean, the mentoring from the people who have done a lot of jury trials is always key because they say you're kind of like a teacher. You're there to teach the jury this is what the concepts of what we're talking about. And if you can do it I mean, the best witnesses are the ones that know how to speak to a jury and present and say, okay, this is the fundamentals of what we're talking about. And then they can get it. Um, and so, yeah, you learn that in business and you learn it in the forensic field for sure. It's communication. So
Yeah.
much of it is communication.
Let's talk a little about the certifications because, again, I mean, communication's key, and I don't think certifications are a substitute for that. I mean, you can be very well certified but a bad communicator and you won't get past the jury. But certifications themselves lend credibility to an experts to an expert. So you yourself have certifications from ACTA, you have the NAFI certifications, the CFEI and the CVFI. So can you tell us a little bit about these certifications? Like, what do they entail? And if you can talk about ACTAR first, that'll be great.
Yeah, so ACTAR is kind of the PE of accident reconstructionists. And there are a lot of accident reconstructionists that come from law enforcement, don't have engineering degrees. But I think the key is it's not so much the letters on your resume for me, it's what it takes to get that. It's not an easy thing. There's a tremendous amount of training and you have to get experience. Same with the fire. Like even just even if you could pass the test, like you need to have experience in addition to be certified. And the ACTAR exam is not easy. It's 8 hours long and there's two sections. And the second section is 4 hours and it's one reconstruction that you're doing. And you're doing a lot of the old school stuff, drawing it out, measuring and interpreting road evidence that they give you. And there's math to it. Accident reconstruction, though, primarily, especially like the momentum stuff that we talk about and how we analyze, get back to speeds, it's like uh, high school math and physics. It's like algebra, trigonometry, physics. And if you haven't used it since high school, you got to relearn it. But like as an engineer, none of that part is hard. The hard part is how do you get the inputs for these equations? And that's where a lot of the tools come in. The drone stuff, it's a tool for me. And all the data and everything. And then it's taking all those different points and putting them together. But yeah, the ACTAR was a feather in my cap, I guess, from that standpoint. It was a goal, definitely, when I started at REMKIS and started learning more about accident reconstruction. And so we were able to get that. And then the CFEI, the certified fire stuff. I had a really good mentor at REMKIS who was a genuine like fire investigator, had been doing it as long as I've been alive. And then I'm the engineer. Like, and that's the way I like to approach the vehicle fires. Some cases, it might be very obvious where the origin is. But in terms of like, especially like if you have a garage fire, the origin and cause investigators can get you to, oh, we think it started with this vehicle or this lawnmower or ATV or something. And then that brings me in and I focus more on the cause.
Mm-hmm.
I mean, you have to truly try to pinpoint the origin within the vehicle, but the fire investigators, it's good to work with them because that's all they work on, and that's a science. And it's fire investigation's not easy because a lot of the evidence gets destroyed,
Yeah.
depending on the fire. But a lot of what we'll do too in that is you'll bounce it off known issues or known recalls on something. And so sometimes there is a recall in a certain area that's a fire risk, and you have a fire that may or may not be consistent with that failure mode. And so the focus in general of an investigation might be kind of like that, like yes or no. But there's a lot of times where it's just undetermined in general. But I'd say with everything, fire, accident reconstruction, everything, certifications are great and they give you credibility, like you say, and get you kind of maybe in the door, but there's no substitute for experience.
I think we recently did a detailed case study on one of those fire accident cases where a hoverboard caught fire and then it turned into a complete battle of experts. And then I think they had used some electrical arc mapping methodology to see what was the cause of the fire in the hoverboard. And yeah, I mean, again, my knowledge is very limited to how the experts was challenged and what the issues were there. But a lot of it boiled down to, again, using reliable methodology and then the court coming down to establishing, okay, which ones were reliable and which methodologies were not reliable. So, um, how important do you think these case studies and expert reports written by other experts, or how courts have dealt with the testimony of other experts in fire investigation cases or accident reconstruction cases where they have talked about the methodology that the expert used? How important do you feel these are for new experts who want to come into the field as a tool to learn from the experts who are already doing this for a long time?
Yeah, that's where the path of getting those certifications, the training that goes with that, you get a lot of that background, but that's the example of why it's a continuing education. Accident reconstruction is ripe with a lot of great people doing research. There's
Yeah.
people who don't do as much casework anymore. They focus on research and testing and validating different new methods, including video analysis, photogrammetry. Um, there's more and more vehicle data available, that the ADAS systems in vehicles, and human factors is huge. Evaluating the response of a driver is almost as important as how the vehicles came together like that. So when you're trying to understand the total thing, and it's never over. So there's always new studies going on, and it's interesting. So it's not hard to want to stay interested in it
Yeah.
because it's cool, but it's the technical community and all these experts that might be or typically are opposing each other at some point. But in the other environment, in the kind of the research environment, everyone's trying to help educate themselves. And so we're all up to date on the methodologies. Then there are things where research papers, publications that have a history of being accepted in courts, as they become more and more accepted, there's things you can actually cite that way that you can defend. If challenged, you can defend that, no, this has been peer-reviewed studies with testing. It applies to this case, and it's also been accepted in these different trials. And so anyway, long story short, yeah, it's especially in accident reconstruction, there's so many methods and there's so much room for argument because there's so much room for assumptions to have to be made by experts. And they may be considering the same methodologies and have the same background, but might be
Hmm.
interpreting things differently. And so it's natural there. I mean, fire, it can happen as well. But yeah, I mean, accident reconstruction is key. You have to stay current. Absolutely.
And tell me a little about the commercial drone pilot thing. So, do you use these? And you just mentioned that you actually use these drones in your investigations. So, what can drone footage capture that ground-based investigation misses? That's the question.
Yeah, the key, I mean, the primary use of my drone is mapping accident scenes. The most critical time after an accident for an investigator is shortly after to get scene evidence because it's going to go away. Fluids, you know, police will paint sometimes. If you're not actually able to get to the scene that quickly, there'll be paint marks on the road. People have probably seen those driving around that show the final positions of the vehicle. There's going to be fluid or gouges and things that will show the point of impact. And then there'll be skid marks and different things like that. And you want to identify them as soon as you can. And getting a good aerial view right over is a really good way. Then you can input it into software and be able to have your scale model and put your scale vehicles over it. I'll use the drone also when I'm looking at large pieces of equipment to get better perspective photos, like
Hmm.
than having to have like a long extension pole with a camera on it. It's just simpler that way to do like a point of interest and take photos and then use photogrammetry to build a model. Like I'll look at ag equipment and things like that that are larger. There's cargo freight damage cases I work on. And so you're
Hmm.
really trying to understand the damage of something hitting a bridge, for instance, large piece of equipment. So
Hmm.
the drone can come in handy. And as that technology continues to advance, there'll be more and more LiDAR capability that can actually replace or at least complement, be a comparable replacement for some of the large Faro scanners that are really the gold standard in terms of collecting point cloud data of an accident scene, which can be used is super important in video analysis, photogrammetry analysis, because if you've got a good point cloud and then you get like a couple pictures that were ground level and kind of show a skid mark, there's software that's amazing that you can bring those two together and you can measure, get accurate distances off of really sketchy photos that you might not think would work. But the drone, I think, is a tool that's really important to have. And you
Mhm.
need, for commercial use, you need the Part 107 pilot license. And so the training for that, bumping here, um, yeah, it comes down to airspace and some of the FAA guidelines of when you fly, how you fly, getting the right clearances. And then, one of the downsides could be weather,
Yep.
wind, things like that. Um, but yeah, I really look at it as a powerful tool. It's one more tool in our box to get good quality photographs from
Hmm.
above. But I always still take I still take ground level as well.
And these are the same drones that people use for recreational videos, or are these like any specialized drones with more powerful cameras that you would use for accident reconstruction?
I mean, mine was commercially available. I think a lot. It depends on the capability of what you're trying to do. I mean,
Okay.
there's LiDAR scanners already that exist. And then, yeah, just performance, camera quality, battery life, things like that. I mean, you can spend whatever you want on a drone,
Hmm.
but typically under 100 feet above the ground, stationary, and I don't see the need personally to
Hmm.
invest much more than what I do. It's just gonna be a situation though. The technology will continue to advance, and I'll have to upgrade at some point. But yeah, it's a powerful tool to have for sure.
And how do you begin your inspection? And how is that the sequence of events usually is? Like an attorney would call you, or the insurance company would call you. Like how does the process begin, and what are the different stages of the process that are involved in you being used as an expert witness in accident reconstruction?
Yeah, and there's a variance in the timeline. I'll get called, like a rapid response situation. I've been to scenes when the vehicles have yet to be moved, and I'm going to the state trooper and being like, "Can I be here? Can I take pictures?" And they're usually pretty good if you approach them the right way and everything. Everything from that to, hey, this accident happened 3 years ago or something. And then you're really dependent on the data that already exists. But I mean, first of all, you want to understand who the players are. Like, who are
Hmm.
we representing? What other vehicles are involved? And then you want to get a lay of the land of what they think happened, just generally, the details, who, what, where, when, why. And then I'm always keyed to know what information is available now and what information is going to be available still. Are the vehicles secured in a secured location where they will be able to be inspected later? And in a crash that just happened, if you know, okay, either the state patrol is going to impound the vehicle, in which case you might not get to look at it, but at least you know it's secure for a little while, or that it's going to a impounded like tow yard or maybe the vehicle's in a Copart or something, one of those salvage type places. So you just want to at least identify what exists and then start putting together a plan. I think, again, attorneys that work a lot in reconstruction kind of know what information is important to us and they're looking for the same thing. But that's the part where it is kind of consulting. Sometimes you're like, hey, it's pretty important we look at this. It might be the other side's vehicle, but we need to request this, this, and this. This is what I want to do. This is why I need this information. And especially with commercial trucks, things are changing a lot where you go, hey, I need the VIN and I need to get some more information about because it might change what I would understand to be what data might exist because there's the ABS modules, there's the engine itself, every engine's a little different. And then there are more and more cameras and things like that are being added. But yeah, I mean, the scene is in terms of inspection, the scene's the priority.
Hmm.
And part of my scene exam more and more is looking around for cameras, traffic cameras, surveillance like a gas station or something, and ring doorbells. And I'll just knock on a door or leave a note, even like, and that stuff is important because that will go away. It'll be overwritten. Um, and it's extremely important to get it and to get it in its native format. It's better than nothing, but when you get like one that's a cell phone video of a screen showing a video, you're kind of like, it's a little harder to make sense of. Ideally, you can get in there and get cooperation to get a native format video, especially like a surveillance type cameras that might be at a business. They're like tied to a DVR, and it's funny that a lot of people don't even know how to run them, like their own one. They don't. I've had some where they just go like, hey, go through the menus and figure it out. You're just trying to export and trim enough. And then the other thing about investigations is if the state patrol or somebody is doing an investigation, typically in like a fatal, there might be, if you're coming in late and you're not going to be able to do the inspections or something, and you're relying on their information, you might not get a little bit, you might not get much for a little while. And then once they work through any charges that they decide to do or whatever, or they close their investigation, then you can request it. And then you get like gigs worth of info, and dash cams and body cams and measurements that they take. Law enforcement, they go through the same training stuff that we do. A lot of times you're like, oh, they know they're doing exactly what I would do, but also it's worth checking their work as well. There's mistakes that happen. And so you can't take anything as gospel. You have to really review everything, and it's worth reviewing everything. And I try to do upfront work before an inspection. So I already have some idea of like what I'm really after, um, and then just get my head around it. And then I'll be more observant when I'm there too, to go, oh, this is something I didn't think of. Like, we need to look at this, So in terms of advice for attorneys and stuff like that, we're going to bug you to get everything we possibly can, and we're going to want all of it. And we're going to want to do some work before running out there. I mean, the rapid response area is like big in commercial trucking for sure. Defense attorneys for commercial trucking companies, like, they will support getting you out there immediately. Like, preservation of evidence is like key to them. And I guess just in general, like that's key to get out there immediately. But sometimes the rapid response work is me helping understand, okay, this is where this vehicle is located. Like, we just identify, like I'm there doing work like identifying the parties and who owns what, and as much as just like a hardcore inspection, like I try to look at the big picture because we're investigating this. When I was still back at Polaris, it was like a 1 day, but it was at the NTSB in Washington. Obviously we're used to them investigating aviation accidents. They do highway as well and rail. But again, this is before I took any of the ACTAR stuff, when I was still at Polaris, and I did it. And they were talking about investigation of highway accidents. And they really break things down. And it kind of reminded me of that, because it's like, what are all the factors? And a lot of times in accidents, there's multiple things that line up, but there's human factors, there's mechanical factors, environmental, all that stuff. So you always try to keep that in mind. What things could have combined into whatever type of accident happened. So
So what I'm hearing is that not only do you have to analyze the evidence that is presented to you, you also have to figure out where else can you gather more evidence by looking at nearby CCTV cameras, by coordinating with the state troopers who are already there. So it's more of a full picture thing. It's not that the evidence will be brought to you and then you have to do your analysis. And how do you even go through all these gigabytes of, like you said, that at times you'd be dumped with gigabytes of data from the site of the accident or from the cops. So, I mean, are there specific tools that you would use to then analyze all of this data? Or are there like specific techniques that make it manually possible to do that?
I think when you get a whole trove of documents, you'll prioritize. There's some medical record stuff that maybe I'm not super interested in, but you kind of have to go through it, because there could be a detail somewhere in some file or some deposition testimony. Like, we'll get that too. They'll have to review deposition testimony from different witnesses or witness statements or whatever. And then the cameras, body camera or something, like those are long files sometimes. But you have to watch them. You have to pay attention because you never know what you might see. So yeah, you have to go through it. You try to prioritize it for what you think. But I mean, there's like file management stuff. Like you don't even know where things are organized. Like some people are better than others at organizing it. I've seen some really good ones.
Hmm.
Sometimes by the time you get a big trove of data, there's the state patrol full report in there too. And some people, there's different philosophies on that. I think some people are like, I don't want to hear their opinion. I want to do mine first.
Hmm.
Um, Other people, I want to see it all. And then I won't make a judgment on it until I
Yeah.
kind of do my whole thing. But because there's information in there and it's organized kind of, again, them summarizing what they thought was important. But yeah, I mean, it's not like there's an AI app or anything that's going to replace what we're doing on like having to look through stuff.
Oh, definitely not.
You have to, you don't want to, yeah, you don't want to miss something and be like, well, it's because I didn't look into it, that it was existed.
And how does the data usually come? Like, because I've seen some attorneys would just send a Dropbox link with all the files in one folder, and then the expert has to now sift through all the files and figure out what is what. So, does that happen often, or you would see attorneys getting organized about the evidence, and you'll get files that are labeled, or they are organized in folders, or they do some document management system and they send you a link to that? What's
Yeah,
your experience been
that's
like?
probably file share links are probably the most common, but I will get flash drives from the state. More times than not, it's kind of like from the law enforcement side.
Mhm.
You'll get from their records department like a flash drive literally in the mail that's got everything on it. But yeah, I mean, you have to be prepared to store. You need to have the infrastructure, I guess, to store all this data plus all the data you generate
Yeah.
and make sure that it's being backed up. It's always kind of a concern, but
Hmm.
I try to make sure that I share, especially like data I download or whatever, to with the attorney. I mean, anything legal you want to understand, like you want to communicate about, okay, do you want me to have it or you or both or whatever. But yeah, there's a lot of files, a lot of gigabytes worth of stuff out there. But yeah, I mean, in some cases, the more info, the better. In some cases, it's like it can be overwhelming. But I guess I'd rather have access to more
Yeah.
data and just try to sift through it. But yeah, ultimately, like I said, some of the calculations and reconstruction are basic. But if you don't know what variables to put in them, if you're not, or if you're not confident in the variables put in, you have to provide some uncertainty, some error to it, and then it can compound. And then if you're like, well, they were going between 50 and 80 miles an hour, like, is that going to really be beneficial? So I mean, a lot of times you report speeds in ranges. We want that range to be as tight as possible
Hmm.
uh, with the highest confidence.
So, John, it looks like you've had an amazing career till now, and like varied experiences from mining machines to a super cool, yeah, like the three-wheeled vehicle, and then about 7 years at Rimkus. So then, what prompted you to then finally go solo? Was it the urge to be like a business owner? What's your take on that?
I think freedom, kind of
Mm-hmm.
autonomy. I felt like more and more confident that I could do this on my own. Um, I don't have employees right now. It's just me. I don't desire to grow it into a business where I have employees yet, but I would never say never
Yeah.
because never dreamed when I started my career that I always kind of figured you work for a company and that's it. But I'm lucky to have a wife who's very supportive and she has a career, so that it kind of afforded us to be able to do this. And so far it's gone well. It's definitely gone well for the first year, and it's got enough momentum that I feel
Mm-hmm.
good. And I think one of the cool things about this type of a career is you're more valuable the older you get versus maybe less valuable or less appreciated. Some companies they're going to want to get you out the door when you get older, versus this, the more gray hair, the better.
Yeah.
So, and fairly young for this field of experts. I mean, I've been out of school for 20 years, but still there's people who've been doing this 40 years plus. And being on my own at some point, you're going to want to take advantage of the work that comes in, but I don't know, someday in the future, I may want to still work some, but maybe not take more cases, but I don't know. I mean, at this point, I'm like, let's keep tabs on what we want to do in kind of the 5 year, but like, this seems like something being on my own. I really have the anticipation that I'll be able to do this for the rest of
Mhm.
my career if I want to.
And what are you doing differently as a solo practitioner as compared to being a part of a team at Rimkus?
I think it just offered me the opportunity to just process stuff,
Mm.
keeping things just it's necessary when a company gets bigger to kind of have processes and things. And I could really just try to keep things as simple as possible. And I'm able to manage all of the administrative side of things right now and just general bookkeeping and all that. I got the bandwidth to do that, which is good. The more I can do myself, the better. And again, it's like my focus is all on core stuff, what's worked and what's making a difference, I guess. And so,
And
yeah, I've always kind of thought, like, as in my career, like, well, if I was in charge, I would do this thing here different or whatever. And I'm not saying I'm always going to make the right decisions, but at least it's like, okay, I'm making this call. I can just decide to do this or that or whatever. Or I see an opportunity to start to get more focused in this other new area, this emerging technology. And, you're not answering to anyone per se. So your career development, you have to fully take ownership of. Marketing, you have to take fully, control of because there's no one else. So, but it's also kind of energizing. So I love it. I'm so thankful I've done that and experienced that. And, ultimately, if I decide I don't like doing it on my own and I would prefer all this other stuff be handled by someone and I just want to go work somewhere, then I feel like that opportunity it would exist. But I'm not approaching it like there's a plan B right now. It's all everything I can do.
yeah, I mean, you're not stepped away from the field because you're still doing accident reconstruction, you're still doing the analysis, you're still staying updated, staying current with the new latest technologies. So I mean, I can't even imagine that being an issue. But again, I mean, you have a long career ahead of you before you can even think of, okay, like, do I want to take less cases or not? I mean,
Yeah.
you're
Yeah.
clearly,
That's not a
you're,
concern right now.
yeah, pretty young right now. So,
Yeah. I mean, I do have a 8-year-old daughter, and
uh-huh.
so I wouldn't want to be working like 80-hour weeks right now while she's young. So, and that's not the case. So,
Hmm.
again, I'm able to focus on the core stuff and be around more. That's good. I mean, travel is a big thing in this
Yeah.
type of career with inspections. It's a balance, but yeah, I mean, it's been great.
Hmm. And how do you get the word out? Like, I'm sure you have your personal relationships with attorneys you have worked with in the past, but beyond that, what are some of the tools that you found useful that probably other experts can use to get the word out about your now the solo practice that you've set up?
Yeah, I mean, ultimately, the best thing is word of mouth,
Hmm.
but um, you do want to also try to stimulate that a little bit too. And I think just making sure everyone knows you exist is like the first part. So you do the LinkedIn and your website and stuff like that, and meeting, trying to get in front of client bases, attorneys or insurance or whatever. And one way that experts will do that a lot of times is by presenting CLE courses for them, get a captive audience, you get an opportunity then to speak with them and make an impression. I mean, this podcast is great too. I mean, because it's a conversation that people can listen to on demand later. It'll live forever. So, um, yeah, I mean, it's about awareness, but it's really about talking to people individually. And another thing that's I've gotten some referrals from other experts, reconstructionists or fire investigators who aren't engineers who have a case that requires an engineer to come in. Then I'm not really a competitor per se. But they're referring me in, and that's good, you know.
Mhm.
And so it's almost there's a word of mouth from the expert side too, the expert community. Again, you might consider us to be competitors, but at the same time, I feel like there's a lot of cooperation I've experienced, which is good, helping one another stay current and maybe referring each other. Everyone's kind of got their areas that are really specialty. A big thing for me is there's a lot of case crashes that start to go a biomechanical avenue
Yeah.
or a very detailed human factors, very specialized human factors area that I want to make sure I don't get out over my skis, and I know people that are really qualified that I can refer, and the clients appreciate that too. They appreciate when you are saying, "Hey, you actually should probably get this person involved," and stuff like that. So, but yeah, I mean, as it gets going, talking to experts who have done this for a long time, who are busy, they honestly don't even like market at a point because it's just there's enough work from word of mouth. And but yeah, I'm still in that first year, so it's progressing.
No, I mean, again, I think it's a spectrum where
Mhm.
there are experts who are looking actively, and then there are experts who are declining actively, and then there's everybody in between. So again, like I completely agree with you on the referral side of things, that if you're an expert and a case comes your way, it's not a good fit, do not try to do it somehow, and because those are the cases where there's the biggest risk of getting challenged and getting excluded, because you thought you would wing it, or it would I mean, it's not that outside your area of expertise, but that is where most experts, even the most experienced and qualified experts, get attacked and they get butchered. So and attorneys, they always appreciate a referral, because nobody wants to pay $2,000, $3,000 to a third party to find an expert witness. So
Mhm.
if an expert can be found through a referral from another expert, I mean, I can only imagine the attorneys being grateful for that lead. So I think that's the right thing to do. Before we let you go, John, and this has been a great conversation. I mean, I've learned quite a bit about accident reconstruction, and I wasn't aware that drones have become such a key component of accident reconstruction investigation, but it makes complete sense. So before I let you go, for attorneys who may want to retain you or reach out to just have a chat about a case, what's your geographic coverage, and what types of cases, other than like regular accidents and vehicle fires, what are some of the other types of cases that you are best suited for?
Yeah, I do mechanical failures, mechanical opinions on damage. I kind of briefly mentioned about the cargo situation where
Mm-hmm.
you have a large piece of equipment and there's a discussion. It's not about what happened. Everyone knows it hit a bridge or something or hit some, or shifted in travel, but they want to know, okay, what components were damaged, what makes sense, or are they, what could be repaired. Other times there's a mechanical failure in a diesel engine or something that maybe led to a crash, suspension type issue, wheel separation or something like that, where it is more of a mechanical forensic job. So I do those as well. I really kind of look at it like I'm a mechanical engineer, licensed, and that overlaps with reconstruction and fire a lot of times too. And I do kind of the full reconstructions as well. Um, but yeah, that's kind of where the base of what I present as a mechanical forensic engineer. I'm also open. It's not a huge part of my practice, but the not only the figure, the ideating, consulting with a company how to maybe fix an issue, because that's exactly what I did at Polaris and Caterpillar. So maybe being on the side of helping prescribe solutions, not just identifying the failure mode or the cause. But yeah, wherever my experience can be of value, I try to take that on.
Mm-hmm. And where can our listeners find you? We'll add the links in the show note.
Yeah, yeah. I have a website that has all my info. It's not crazy. complex website, but it's jzengineering.com. I'm on LinkedIn, things like that. My email is john@jzengineering.com. So yeah, feel free to reach out to me. Again, it's not like you'll have to go through a lot of people. It goes straight to me. So, yeah, I'm available, and I think it's very important in this field to be responsive to emails and calls. If I miss, I will get back to you.
Yeah, that's a big pain point for a lot of attorneys because they try to reach experts and they don't hear back from them.
Yeah, so I always try to respond like immediately, same day. If nothing else, just to say, okay, I can get back to you tomorrow maybe or something like that. But yeah,
Hmm.
that's really what I shoot for.
Yeah, and I mean, we had a great experience when we reached out to you for the podcast. So yeah, I mean, I can, like testify to that, to your responsiveness for sure. So, John, before we wrap this up, any thing that you would want to add that I failed to ask you?
No, I mean, no, I thought it was a really good conversation. I want to lay out my experience, and so people might recognize, and I'll get jobs where it's like it's literally a piece of Caterpillar equipment or Power
Hmm.
Sports, what maybe not the same companies, but if people have it in their head that, oh yeah, I know this guy, this is an accident involving something in Polaris or some other power sports vehicle, that he's going to have knowledge not only of accident reconstruction but of these specific
Yeah.
products. And you mentioned my area of working. That's primarily around the states around Minnesota, but it's kind of like the more specialized something gets to me, the more likely I am to fly anywhere in the country. Um, and I'm open to that. It's just kind of depends on the case, but you're more likely to keep building a base of clients in wherever you're geographically located. But yeah,
All right, thank you so much, John. This was great, and I wish you the best in your new endeavor as you've gone solo, and we hope you all the best and all the success.
yeah. Thanks, Ashish. It was great to be on.
Yeah, likewise. If you found this podcast useful, remember to subscribe and give us a review on Spotify, Apple Podcast, YouTube, or wherever you listen to podcasts. This will help other users find this podcast and benefit from the insights shared by our guests. If you'd like to be featured as a guest on this show, please write to media@xlightum.com. See you in the next episode.